Taguchi design of experiment and fractional factorial design. Now, Taguchi is a fractional factorial design. It is even more fractionated than fractional factorial design. Now, because it's a fractional factorial design has whole lot of theories behind the scene. For example, design resolution, alias structure. To understand them, watch these two videos. However, design resolution, what it means is basically like a computer monitor or screen resolution. The higher it is, the better the monitor or display. So the higher the design resolution, the better it is. However, Taguchi design was originally created for the lowest possible resolution, which is resolution 3. Alias structure, basically, to simply understand alias structure, is what the word says, basically aliases. So let me explain with an example here. So for example, in this L8 orthogonal array, we collect 8 experiments. We do 8 experiments. So we have 7 degrees of freedom. So you can maximum test 7 pieces of information. So either we can test 3 factors and they're all possible interactions, or we can assign a factor right here, let's say D. In that case, we won't be able to see the effect of AB if you're assigning another new factor here. Let's say we don't care for this AC interaction. We want to assign another factor here. We want to assign another factor here, another factor here. So in that case, we can go up to 7 factors. In that case, we won't be able to see the second order interaction, also not the third order interaction. Now, the alias is basically this AB is aliased with D. Alias means it's kind of like a pseudonym, so it's not really a different person, it's the same person. So D is a pseudonym for AB. So to understand more about alias structure, check that video. However, so AB is aliased with D, AC is aliased with E, BC is aliased with F, and ABC is aliased with Z. So alias structure, design resolution, these are very important things for Taguchi. Now, even though Taguchi gives you these nice interaction tables, linear graphs, to understand them, how to apply them, there are 2 videos right here. You can watch them and see how to apply them. However, without understanding the design resolution or alias structure, when you assign this interaction in different columns, it might not make any sense. So in an apparent look, Taguchi looks easy, but to really apply, you probably need knowledge in the fractional factorial design, at least some level of blocking, confounding, how to do half fraction, quarter fraction, design resolution, alias structure. If you really want to apply Taguchi correctly, you need to understand fractional factorial, because Taguchi is not really something new. He used the same fractional factorial theory which was invented before 1950s. Both of these papers were published in 46, 47, somewhere around that time, and he just used it a little bit more easier way, presented in a way so that a non-statistician can use design of experiment and run the experiments. However, to understand or apply correctly, I would say you probably need this fractional factorial knowledge.